Welcome everybody once again. Before we start, I would like to introduce myself. My name is Christopher Kalolo or Mwalimu Kalolo, as many know me. I will be with you guys uh, in this journey where we will be making our hands dirty, learning about Git, how Git helps teams to collaborate, how Git, how Git helps the uh, version control, how it helps you to manage your workflows, how it helps you to track your files, how it helps you to track repositories, but also how it helps you to contribute on online public repositories. So we will be together, and I hope that we will have maximum collaboration with you guys. And whenever you think that there is something that needs clarification, I will always be available to I'll always be available to facilitate, to clarify,
Eu.
etc. So I will start with the very basic theory before we do anything that makes our hands dirty. I will start with the foundational concepts so that we know what we are doing, why we are doing, and thereafter we will go straight into examples. We'll do everything uh, practically, and therefore I think this will be a right approach for you guys to upskill your knowledge on Git and all its advantages that comes with it. Thank you very much and welcome to the board. So I will start by sharing my PowerPoint so that we can learn a little bit about the underlying concepts behind everything that we are doing. So today is day one. Although we are saying it's day one, we might break it into several days, maybe 2 days. Two sessions, maybe this this Saturday and the next Saturday. But if we are lucky enough, we may exhaust everything today, and nothing will go wrong. Yeah. So I hope my screen is visible, especially my PowerPoint presentations. Please, if you're not able to see my screen, you can just tell me. Are we able to see the screen, please? Someone, are we able to see the screen, please? If you are able to see the screen, even if it's one
Yes, yes.
voice.
Yes, you are
Okay,
able,
okay.
sir.
So today I will be introducing it, as I said earlier, and version control. The goal is to understand version control basics or fundamentals. And after that, we will get hands-on with the very basics of Git, the very basic Git commands, etc. As I introduce myself, you can see the name on the screen. My name is Christopher Carroll, as I said, working at the Eastern Africa Statistical Training Center as a data science instructor. But also, I am a programmer, a software engineer who have worked through several projects, including government projects, personal projects, etc. So I have a little bit of experience using Git and the Git platforms such as Bitbucket, GitHub, and GitLab. So for the purpose of this training and this workshop, we will be using GitHub I will show you later how we set up GitHub accounts, how we set up online repositories, and so forth. So please just follow. So we are expecting to see what is version control because I said Git is for managing workflows, for team collaborations, for file and online repository tracking, for online public repository contribution. So what is version control? And not only version control, but we are also going to look at the types of version control, centralized versus distributed, and why do we use Git for version control and the way Git works. Yes. So when we are doing any project, it might be a coding project, it might be data analysis project. I understand that we have people who are purely statisticians working with scientific tools such as R, Python for data analysis, for data modeling, machine learning, but pure software engineers as well who are specialized in coding and stuff. And now we understand that in an environment where we do a lot of coding or a lot of changes in these files, most of the times you will find that as time goes on, you will be making changes, modifying your files. At the same time, the old files will be, the changes which were on the old files will be lost. But we understand that some of the guys are intelligent enough to rename files. So every time they make a huge change, then they will actually modify the previous file by renaming them, these files, or maybe they will copy the previous file and then rename it, paste a new file with a new name. They maintain the old file so that in case anything happens, they will be able to go back to the old file. So since we understand that changes happens over time, since we understand that projects uh, does not actually project does not run by a single person or individuals, most of the time you'll find that projects are worked on teams. So teams collaborate, make a lot of changes, and therefore, in that very scenario, you will find out that version control is of paramount importance. What is version control? We are talking about being able to track your versions of your files as you make changes. And as I introduced earlier, we find that some of the guys will use traditional methods, renaming files so that they can keep the old file and the new file, etc., etc., etc. All those are version control. But now we are introducing the modern way of doing the same thing so that you can do it effortlessly, but maintaining high standard of your work. So these version control systems actually, we have the centralized ones, a single saver, but we have the distributed ones. We call such as Git. And when we are saying distributed, we mean that every person have got their own copy of the repository. So if you have a team of 5 people working on a single project, every time and everywhere, each team member or each participant in their machines, they will have a full copy of the repository of the project they are working on. And that's why we are saying that is a distributed version control system, because each of the team members will be having a full copy of whatever they are doing. And this workshop will be concentrating on distributed version control system. Git provides flexibility and speed. Git also provides offline access. So you can work with Git entirely into your computer without connecting to the internet if you don't need to. You will only connect to the internet if you want to track an online repository. But if not, it is very okay to work with Git offline. And the full history of your changes to these files are stored locally and in the most widely adopted distributed version control system. As for me, I'm not sure whether I have worked with any other system other than Git. And Git powers GitHub, powers GitLab, powers Bitbucket. As I said, in this workshop, we will concentrate on using GitHub as a platform. I understand that GitLab, Bitbucket, they follow the same principles, but we will not be moving through these different platforms. So we will use GitHub. And when you have time by yourself, you will explore GitLab, you will explore Bitbucket, and you will find other systems that works with Git. And the key concepts here, we are talking about the repository. The repository is a project folder which is tracked by Git. So these are the very basic concepts that you need to keep in your mind. Number one is the so-called repository. A repository, every time you will hear me mentioning repository, is a project folder which is tracked by Git. And something called commit. Commit is a saved snapshot. So these are the very basic concepts. A commit is a saved snapshot of your files. We have something called a staging area, which is a middle ground where when you modify a file, for example, then before you commit, that file will be added to a place or a virtual place called a staging area. And then you have a working directory, which is your directory that keeps your files on your disk. So why Git? As I said, if you look at this scenario, for example, we have developers here, and each developer is doing their own task, as you can see in this picture. And now you see there is no collaboration between these developers. So if there is no collaboration, that means the versions are not maintained properly. It is time consuming because it will require that these developers, after everybody have done their part, then maybe they select one developer with a master computer and send their project file there. They will have to merge the files. They will have to make sure that the project is running despite the fact that the files are coming from computers and every person is working on a different computing environment. In case the server crashes, there is no choice of recovery. There is no backup as well because every individual is working separately from the other. This is now is before Git. Before Git. If you look at this second picture, you find that after Git, now developers are working from their computers, but they have a shared repository. And every person will be working on their task, and they will be sending files to a central repository whereby every other member will be able to access the files of another team member. So this enhances team collaboration, and the versions of your software will be documented and maintained accurately. This saves time as well because you don't need to be moving your flash disk from one computer to the other collecting files so that you can merge the project to be one project. automatic backups, and it is very easy to use as well. So that is the before and after Git. That scenario shows you the before Git and the after Git, and you see now that the introduction of Git gave a numerous advantage to the programmers, to the analysts, to everybody who is working with these platforms. And therefore, it is very easy for you to work with large projects, to work in large teams, provided that you know, or provided that your computer will be able to track an online repository, etc., etc., etc. So, in a normal setting, you will have a GitHub remote server. We have not started with GitHub, but I will be mentioning because they are just basic concepts. In a normal setting, you will have a GitHub remote server. This GitHub remote server is where your online repository will be residing. And therefore, each developer will be having access to that online repository, which will be tracked by their local repositories. So every developer, every analyst, every person working on that particular project that is tracked by Git will be able to access the online repository from their local repository. And therefore, this enhances team collaboration, as I said. Uh, sorry. So Git is a software tool. Mm. As I said, use track to track changes in the source code. Multiple developers can work together. And of course, some of the guys are asking, is Git only for developers? And I said, no. Even a linguist can use Git actually. If they are working on a particular book, they are writing a book, and every person is given their chapter within a document. They can collaborate by using Git. They can collaborate by using Git. We have people who are very eloquent using Markdown technologies and other similar technologies. You have people who are working on data projects. They are analyzing data, they are doing this and that. All these personnels can work by using Git platforms to collaborate on their work. The architecture of Git is, as you can see, now you have a working directory. For example, you are developing a system and you are saying this system is called, say, uh, restaurant management system. So actually, you will have a working directory where all your files results there. That folder or that directory will be called maybe a restaurant manager, for example. That is the working directory. And therefore, this working directory is where you add your Git tracker, where we say now your working directory transforms into a local repository. So every time we work with files, in order for you to be able to track these changes you're making on your files, you'll be adding these files to a temporary place called a staging area. So the architecture starts from the working directory. When you make changes, you will be adding these files. You create a new file, you change content into the file. All these files, after you create a file or you make any change, will be added to the so-called staging area, which resides on your local computer. And then, if you want these changes to be snapped, to be kept, to be taken as a picture, that is a history of your changes, then you will have to perform something called git commit. So you will have to commit your changes into your local repository. So you have a working directory, a staging area, and your local repository. After you have committed your files into a local repository, then your files now can be seen by your remote repository. So if you're working with a team, you understand that, okay, your fellow members, when they are adding files to the remote repository, now you can pull files from the remote repository to your local repository. And you can push your files from your local repository to your remote repository as well. So in order for that to be possible, then you must commit your changes. And in order for you to be able to commit your changes, you must add these files and the changes that you have made to the staging area. So the communication that happens between the local repository and the remote repository is the push. So we have a command called push. Pushing files means moving your files, not moving actually. Actually, you are sending the copy of your files to the remote repository. And if you want to have any changes from your fellow colleagues working as a team, they have pushed their files into the remote repository. In order for you to be able to get those copies, you will have to fetch them. You'll have to pull them by using the git pull command, which we'll see very soon. After done with your changes, you can merge the new branches to the master branch. Actually, we will see all these because we have a lot of concepts to discuss. Now, let me speak not about Git checkout, but Git merge. What is it? Git merge is a command actually, but this happens when, for example, you and your fellow team member are working on the same file. So if you're working on the same file, for example, sometimes when you're working on the projects, we have these files which are common to every team member. For example, the file that contains information about database connection is the same file. Now, if someone is working by using, for example, Ubuntu, and another person is working by using Windows, you understand that the directory structure of Ubuntu and Windows is different. And if that is the case, then when your file is in your local repository, you will have to give or to configure your file path by using the structure of your computer and the operating system. Now, if you mistakenly push this file into the remote repository and then your team member pull that same file and they have a different directory structure, that means there will be a collision because the same line in that particular file will be reading two different content. And in that scenario, then that's where you will have to merge the content, your content and the content of the other team member. Now, how do we install Git? We install Git on the Windows. For those who are using Windows, we will start by those who are using Windows. Just go to your Google search engine. Just write Git. Let me go there. We have given this link here, git-scm.com, download win. But you can just write, you can go on your browser. You can go on your browser. Sorry. Okay. So you can just write Git here. I think if you write Git, are you able to follow, please? Are you able to see what I'm seeing here? I'm on Google now.
Ndio tunaona.
Okay.
Yes, we are seeing it. No, tunaona.
Yes, sir, we are seeing.
Thank you. So this is the official site for Git, as you can see, git-scm.com. If you go there, you will be able to see a lot of information. But as you can see here, there is a link. Now it is detected automatically because for now I'm using Windows, and I believe that most of you guys are using Windows. That's why I decided to train by using Windows operating system. If you are on a different operating system, I will show you as well how we go about that. So you just go and click. So if you click, you will have, you see you have Windows, you have Mac, you have Linux, you have whatever. Now, for those who are using Windows, just go and click Git for Windows setup. It depends on the type of your processor as well. So you need to know if your processor is this kind here, ARM64 or the normal processor, Intel processor. For those who are using Mac, you see, this is how you install Git into a Mac. You use brew install Git. For those who are using Linux, you know, you always use uh, you use commands. So also you'll use apt install Git. It will install directly. And the good thing is that for those using Mac OS and Linux, it will install Git, but also it will install all the dependencies that are required. After you have successfully installed Git, so somebody wants to see that I have also downloaded this file. So let me download it for somebody. But you know, the procedure for installing Git is the same as for installing any other application. No fancy procedures, no gimmicks. It's just click next, click next, click next, agree to terms and conditions, you know, all those stuff. And then you'll be good to go. So you just install Git that way. Once you have installed Git, what you will be required to do is to confirm whether Git is installed into your computer. How do you confirm that? You confirm that by running, either you run your terminal, your command line interface, for example. If it's for Windows, you know, you have CMD. So you will go to your, now you have downloaded this file, Git, blah, blah, this here. Then you can just click and you will see that because it's just a normal setup, then you will proceed that way. Now, I will not go through this process because I already have Git in my computer, so I cannot install it right away because Git is already installed in my computer. But you follow these procedures, I think you know how to install a software. A software. Well, after showing you how to get the Git setup file, then you go into your computer. For example, here I will type CMD for those who are using Windows. CMD, just click CMD and then check if Git is successfully installed. So you write Git and then you write dash dash version. So if you get a response such as this one you are seeing here, Git version 2.4.3.0.Windows.1, that means Git is successful installed into your computer. Then, if it is successful installed into your computer, you are good to go. Then you can start exploring it. So we come here to the second procedure. We now see. So for Windows, as I said, this is how you get it. And then when you are installing Git, now because I said that you know I've already installed Git into my computer, but when you are installing Git, you have to choose Git bash here, right? Uh, in the context menu, you will find it's not something fancy or something strange. It's just that you'll check it. Make sure that you check Git bash here, and I will tell you why Git bash here. Oh, okay, and then you choose Git bash as the default terminal emulator. Now, why do we choose Git bash? It is because Git bash gives Unix or Linux-like terminal. So you can use Unix or Linux like terminal into your Windows. You'll be able to mimic that terminal. It's an emulation of a terminal which looks like Linux or Unix. For those who are using Ubuntu, you are using, other kind of Unix-based systems. So it's a Unix-like shell. I will show you how it looks like. After you have enabled Git Bash, when you are installing it, then eh, every time you want to use Git Bash, you'll just go to the folder that you want to open through your terminal. Right click on that folder, and then it will say Git Bash here. If you see Git Bash here, when you select Git Bash here, then a terminal emulator will open. For example, now because I also installed Git Bash, I enabled Git Bash. If I come to uh, this, which is written, this folder written 2026. If I right click this, you will see somewhere Git Bash, Git Bash, Git Bash. Okay, you see it? Open Git Bash. I mean, open Git GUI, open Git Bash. So if I click open Git Bash here, then I have this terminal. Now this terminal is Unix-like. It's the same terminal you see with people working with Ubuntu and Solaris and Kali Linux, etc., etc. You see something like this. So even in this terminal, I can check the version of what? Of my Git. And in this terminal also, I will be able to run commands that are Unix based. For example, if you want to clear the screen in Ubuntu or in Unix or any system that runs which is Unix based, then we always write something like clear. It clears the screen. This is the same thing you do with what? With Windows, but Windows gives you a different approach. So with the Windows, for example, you open the command line like this, and maybe I just wrote Git version, something like this. I check Python version, whether I installed Python, maybe something is not there. Now, if I want to clear this screen, I don't write clear like this because this command is not known in Windows. In Windows, I do something like CLS and it will clear my screen. But you saw that because I'm using an emulator, a terminal emulator, by using Git Bash, I was able to write clear. This command is not for Windows, as you saw when I was running the same command in CMD. It didn't work, but here it works. Why? Because this is a Unix terminal emulator. So this is very important for you to make sure that while you are installing Git, make sure that Git Bash here is checked, is enabled, so that when you are installing Git, it will also install Git Bash. But also for those who are doing Windows, we have another called Windows PowerShell. Windows PowerShell. This is Windows PowerShell. And you see you can Git version is a kind of, you know, an emulator as well, because if you write clear, it works. I think you saw what I did here. Let me repeat again. Git, for example, version. If I say, for example, Python version, which I know I didn't, I have not installed Python here, but I just want to show you what happens. What if I say CLS? It works. If I say clear, it works as well. So this emulator, Windows PowerShell, combines the power of CMD or command line interface in Windows and the emulator in uh, Unix terminals. And so you can write all these commands together. Okay. After that brief introduction, let me go back to where we were. Okay. So as I said, installing Git on macOS is very simple. Just write a brew install Git. I'm not using Mac, so I will not be able to run that command. You verify installation by writing Git hyphen version. For those who are doing Linux, you just write apt install Git. It's shortened for apt-get install Git. And if you want to have administrative privileges, is sudo apt install Git. Thank you very much for that very first part. Now, after you have successfully installed Git into your computer, you want now to start tracking your projects. How are you going to do that? So this second session is specifically designed to help you understand how you can manipulate your working directory so that your project will be able to track files and then control your file versions. So we will initialize Git repository in our project. Number two, we will show the basic commands that will give you the best understanding of the working directory in the staging area and the repository. And we will also show how we can track the file changes. So when you want to initialize, or when we say you are initializing a Git repository, what it means is that you establish a Git project within the chosen directory. So you are working in a particular project, any project. It might be writing a book. It might be analyzing data. It might be writing code to any project. Then that parent folder or that parent directory is the particular directory that you will initialize it so that it becomes a Git project. So when you initialize Git, that means you have set an infrastructure for Git to track changes within your directory. And when you actually initialize Git into a directory, you create a hidden file uh, or a hidden subdirectory which is named Git. So if your system allows you to view hidden files and folders, then you will find a folder named Git. So everything that you do will be stored in this particular folder. So it will be part of other files in the root directory of your project. Hmm? Let me show you how we do that. Now, uh, together we will, so let me see. Okay, I'm reading comments, guys. Yeah. So one guy have helped you on how you can enable the Git bash. I think Git bash something like that. Someone has posted, so you can read it. You can read it into your computer, into the chat area. Thank you. Okay, so now let us set a project. Let me call this a project. Maybe let me create a folder. Sorry. So starting here, let me use my Git bash. So we are on the desktop. Create the folder. Use any method that you always use to create the folder. So I'll use this one. I think it's make directory. Let me call it Git Workshop. I think Git Workshop, the directory is already here. Git Workshop, Git. Okay, let me, sorry. Git workshop here. So our Git workshop file is here. We have successfully created our Git workshop. Now, in order for our Git workshop to be uh, a file, I mean a directory that is tracked by Git, what we do first is to navigate into that folder. So for now, uh, we can say change directory, and then we move to Git workshop. Now we are inside the Git workshop. We don't have any files. We don't have any files up to now. No single file. But can we say that this is a Git directory? Yes or no? Let me clear the screen first. Can we say that this is a Git directory? No. Why? Because we have not initialized Git. Now, how do we initialize? In order for you to be able to know whether this is a Git directory or not, you can run a few commands. Let me show you these commands. But for example, you can say Git. If I say Git add, for example, all, I know says Fato, not a Git repository. Are you able to see that? Let me show you. I wrote a Git command. I was trying to add all the files in my directory. It said Fato, not a Git repository or any of the parent directories. See that? So this means that this is not a Git what? A Git repository. If we go and examine it physically, for example, because I think it is somewhere here. Git, somewhere, Git. I don't see it. Let me refresh this screen, for example. Okay. Where is Git Workshop? This file here. Now you see nothing in here. Even if we say we want to see to be able to view the hidden files, you see here we are checked the hidden items. So that means if the directory Git was created, we could be able to see it here, which is different from this Git Pro here. I think this is, you see this? Now, if a directory is actually initialized as a Git repository, you will see something like this here, .git. This is a hidden folder. And when you open it, you will find a lot of what? A lot of files and folders, of which we'll be able to go through every one of these later in our training. So back to our folder. So our folder is Git Workshop here. If you have created it, make sure that you right click it and then Git bash what? Open Git bash what? Git bash here. If you open Git bash here, then you will be able to open the emulator like this one. Now we are inside Git Workshop, right? If we pre-wd print working directory, you will find the working directory is what? Is Git Workshop here. So what to do in order for in order for us to be able to initialize Git? We initialize Git by writing this command git init. If you write git init, that means when you run that command, then your directory Git Workshop will immediately be transformed into what? Into a Git repository. You see, it says initialize empty Git repository in users blah 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 Git Workshop. Inside Git Workshop, it has created a hidden folder called Git. So now, if we list what is inside this directory, we'll find we have the project folder here, .git. Even though we go and physically examine what we just created here, sorry, if we go and physically examine our folder now, Git Workshop, we see now this hidden file, hidden folder has been created. Okay, let us move on. Let us move on. So what happened? We say a Git repo has been created, and then version control is activated. So our project is ready for version control. Files will be tracked automatically, and the Git will be able now to track these files and the changes that we make inside that directory, which is a Git directory. Also, an initial branch has been created, and the initial branch is called main or master. The old versions of Git used to call it master. Now you understand that in this current world where they thought maybe master is kind of slavery, uh, people are fighting against slave and stuff. So they suggest that the convention of default branch should not be master, instead it should be main. So if you see that you write a command to see what branch are you in, if you see master, don't get confused. If you see main, don't get confused. This is the main branch, and your project will be always tracked through your main branch. We'll know about branches in our later sessions, but for now you understand that. So we can be able now to check a few things. As you see that we opened that Git repo directory and we saw objects, refs, and other configuration files. If you didn't see, let me show you. After we have managed to initialize this, if you open this one here, you see we have objects, we have configuration files, we have, the head pointer, we have the references. See that all this stuff, the hooks, we will understand everything as days goes on. But this is what have been created once you just initialize your directory as a Git directory. Well, going forward, so I will not talk about Git clone now. I will talk about Git clone later. So let me skip this. So let us see the commands, basic commands. For example, git init, we just run git init a few seconds ago, and that created an empty git repo. It's an empty git repo. And then we have a command which is a very important command called git status. This command always checks for the status of the current files. And as you remember, I spoke about the staging area, that from your working directory, you have a staging area, and this staging area keeps your changes. So if you want your changes to be tracked, you must first add them into the staging area. After you add them into the staging area, then you have to commit them. When you commit, then you save a snapshot. You create a history where now your files can be tracked by your local repository, but also you can track from your remote repository. So these commands, for example, make directory my first repo. For myself, I did Git Workshop, and then I moved to Git Workshop by using the cd command. Now, for those who are not aware, cd command is a command which means change directory. Change directory. So cd means change directory. So when you are using Git bash, for example, you'll be able to run commands in a Unix style. So just write cd, and then if that directory is within the directory that you are in and you want to move to that directory, for example, you are on desktop and then you want to go to Git Workshop, then you just write cd Git Workshop. That means you are moving from the current directory inside another directory which is also in the current directory. And then Git init, which we did, and after that we can write a file. So for now, let us try to write a markdown file, readme.md. I understand that for most of the software that you guys download, you have a readme file. So we will use a readme file in this session to actually test different commands as we will be seeing as the session goes on. So let us go and create a readme what? A readme file. And we will write our first line. For example, we will say hello Git, like here. So this command here, actually, this command here, what it does, it creates a file called readme.md. And after creating that particular file, it will write a line reading hello Git with an exclamation mark. That is a string, that's why you have put quotation marks. Now, after you have successfully created a file, what you will be required later is to add that file into the staging area. And the command for adding a file into the staging area is git, then you write the words add, and then you write the name of the file. And then after writing the name of the file, you will have to commit the changes so that we can be able to track these changes. We can be able to send these changes to a remote repository. And whenever you are committing these changes, you commit by writing git commit and then -m. M is for message. So that when these changes, because you'll be committing multiple times, now you'll be adding a label or a message so that you will be able to distinguish between a commit and a commit. And when you push these changes into a remote repository, all these messages or labels will be seen there. So if you'll be looking for a very particular commit, you can reference them by using the label that you attach while you are writing the git commit command. One thing to note is that every git command starts with git. So whenever you write a git command, you start with git. And we said the very basic first command is git init. That is the very basic command. Because without git init, that means you will not be able, in any way, you will not be able to change your directory into a Git repository. So first and foremost, before you can write any Git command, you must Git init. After you are done with Git init, now you are free to write Git commands and how you want. So let us see, using this example, as we can see here, we will create a README file. We will add some lines inside. Then we will add to the staging area, and then we will commit the changes so that we can be able to track them. Now, please come with me. Let us come to our emulator. You see, I said if you're using the old Git, you'll see master. But if you see main is also the same thing, is a default branch. So after you have successfully initialize the directory to be a Git directory, you can check for the status if you have any files. How do you check for status? You say Git status. It says on a branch master. It says no commits yet. It says nothing to commit because there is no change that has been made. Right? So number one, we said we will create a file called the readme, and we write the following message inside it. Hello Git, whatever. Hello Git. Mm, Git workshop here. Something like this. And then we write this directly into our readme file. So this is a markdown file, so that's why the extension is .md. If you do something like this, if you say, now we are good to go. Now, if we want to see this file, we can write the command ls. This command ls is for listing files and folders inside this directory. So we can, you can just write that and create. Hit enter. You see now we have created a file called readme.md. Now here, if we run now git status for the second time, you see it will say uh, on the branch master, as always, it will tell us that there are no commits, but it will show us that there is an tracked file. There is a file which is not tracked. And it suggests that you use git add that file to include it to the file that will be committed. What it does, it just adds this file to the staging area. Now it says nothing added to commit, but untracked file is present. So it is suggesting that you add. So what do? You write git add, and then the file name. The file name is readme.md. If you click enter, then the file has been what? Has been added. Okay, after that, what happens next? Now, what if we check the status of our files again? If we say git status for the second time, it says on the branch master, no commits, yes. Changes to be committed. Now you see the messages are changes. Are changing. The first message told us that there are untracked files. And before this, when we ran Git status, it said no commits yet, nothing to commit because there was nothing in the staging area. After we created a file, we made changes. Then the same command said no commits, yes, of course, but we have untracked files. Then what we did, we added the file into the staging area. After adding the file into the staging area, now it says changes to be committed because there is what? There is a file or there are changes in the staging area. So what we can do, we just commit, and the file that contains the changes, the changes that are present in the new file here. You see new file readme.md because we just created the file. How do we commit this? We just write git commit and then -m. I told you -m is for attaching a label to your commit. Next time we are looking for a specific commit, instead of using the identifiers, you might be in a position to need to use a name or a label. So we write -m and then we put a label, and the label maybe we might say my first commit, for example. And then you must make sure that it is a string. That's why you put within the quotation marks, double quotation marks. And that if you run enter, hitting enter says my first commit, one file changed, one insertion, create mode, blah, 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 that one. So now what if we run now the git status again? Running git status saying on branch master, nothing to commit, working tree clean. So the working tree is clean. We have tracked the files, we have committed them. Now, if we want to share the files or the changes with the remote repository, we will be able to do so. Later in our session, we will demonstrate that as well. Back to our theory. So, when we say tracking files or file changes and file history, what do we mean? This is the core function of the version control because version control records everything you are doing in your project over time. So it just saves those snapshots. When you commit, it saves the snapshots. So instead of saving multiple copies that you do when you're doing traditional, because you'll say file number one, and then you make changes. You don't want to lose the older file, so you say this is file number two. You copy the content from here, you put to this file, and after putting to this file, then what do? You make your changes, but you are sure that if anything happens in this new file, I will be able to go back to the old file. You are using traditional methods, but now with these commands, you are doing it automatically. And the efficiency is high. You will be able to travel back and forth. Remember that you will be able to travel back and forth by navigating through those commits, etc., etc. Now I have already explained everything about what is written uh, in this slide. So what I told you is that this is the three-stage workflow. Uh, as you know that this is a workflow management as well. So this is a three-stage workflow. You create a file, or you modify a file, or you delete a file, or you rename a file. Git will automatically detect these modifications. So in your working directory, you have files that are actively edited, and then you will move these files into a temporary holding area, which we call it the staging area. And then these files will be added now to a commit or to a repository by using git commit. So it's a three-stage process. Okay. So we have another command, which is a very important command. It is called git diff command. This command is used to see the precise changes made to the files that have not yet been staged. Git diff staged show the changes waiting in the staging area. For example, you remember that we added some content into our README file. If you open it here, README file, if you open by using maybe in notebook, I think. Is it notebook? Notepad. Okay, you call it notebook in Windows. If we open it by using notebook or text editor, any text editor, you will see that particular line that we wrote. I'm opening it here so that after that, we will then add some other content, and then we will be seeing what is happening with our tracking. You see this line here? It says hello Git works here. This is what we wrote when we created this README file. Now, let us go back to, to our command. Um, we want to we okay, we can change it using what? Using our so I'm using the what do we call this? This is Visual Studio Code. I'm using a Visual Studio Code. You might be using a different editor. You might be using a different editor. Feel free to use any editor depending on how you are following this workshop. If you are following this workshop as a software engineer, you're free to use any editor, any IDE. You might be using uh, PyCharm, for example, if you are testing with Python code. You might be using R Studio. Mm. You might be using the notebook itself, doing R, or you are doing Python. You might be using PHP Storm if you are writing PHP code. You might be using Intel IDE if you are writing Java and stuff. You might be using any IDE or any text editor. You are free to use anything, but I'll be using the Visual Studio Code to effect changes and see what happens. So here I write another thing. For example, what do we write here? This is our first day in the workshop, something like this. And I save. After saving, if I come back to our emulator here, let us check our the status. So we write git status as always. So remember, your git status is your tool, a very important tool. Actually, is your companion, your side companion. Now hit enter. What does it say? Changes not staged for commit. Use git add to update what will be committed, or use git restore file to discard the changes in the working directory. So if you want to discuss the to discard the changes, you just write git restore. But we have another command that I will show you earlier. I mean, I will show you later. So you see what is it? What is this area? When we just created the file and and ran git status, we saw it was written new file. But since it's not a new file, but it has changes, it says modified. Modified. So what do we do as well? We said you can check uh, for what for changes, right? You can say what is different from the previous file. So you say git what? Git diff. Do you see what is happening here? It says when you see something like this is our first day in the workshop in green. For example, here, and there is a plus sign. That means this is an addition. This is an addition. So, because sometimes you may delete something. So when you delete something, it will show a different symbol. So that is an addition. So after that, you can check whether in the staging area is anything diff minus staged. Git diff minus staged is checking whether there is anything in the staging area. Changes are waiting to be committed. And for now, I think there is nothing. So if we run something, we run this command, we see that there is nothing here shown. There is nothing here shown. Eh? Nothing here shown. So, okay. Let us try to add this file, git add, and then our file is readme.md. Well, so now if we write git diff, we don't have anything because the file has been moved to the staging area. But if we write git diff now and then say staged, it will show us this is our first day in the workshop. It has shown us. So that is the very basic command as well to see the changes that have been effected in the working directory or in the staging area. I repeat again, the command that is used to see the changes in the working directory is git diff. Git diff, this one here, and I just shown you how to write it. And then if you have moved these changes, you have added these changes to the staging area, then if you want to see anything to the staging area, you write git diff, then staged. It will show you whatever you want to see. Any changes that have been taken effect will be seen there. Well, we have commands also to track history. Because you are saying every time you write a Git commit or you run a Git commit, what happens that Git records a new snapshot. It's like taking a picture. That is a snapshot. So that snapshot is saved as a history. And it takes these snapshots from the staging area. We say this creates a permanent timestamped entry into your repository history along with a unique ID. A unique ID or a SHA hash and a message describing the changes. So I will show you these unique IDs. How do they look like? But if you want now to see these the history, we have these commands. But before that, we say when you write a command git commit, actually Git doesn't store a full copy of every file when you commit, because now it will take a lot of the computer space of your hard disk space. It will take a lot of space. Instead, it stores the content of files as objects. And uses the system of pointers to reference them efficiently. It uses the system of what? Of pointers. I know that some of you guys are aware of pointers. When we speak of pointers, those who did C++, or those who did C, programming, and the language of that kind, they know what is the meaning of pointer. Is now the way Git works, it works by using the system of pointers to reference the commits. This is why when I was showing you the content of the Git directory, I told you that I see the head pointer inside that directory. So actually, that is the meaning of it. Now let us start exploring the history of our tracking. We said we can run the command git log. Git log show that we have a commit. And the commit says this is the hash or the ID that is referencing to that particular commit. And the pointer is pointing to the master. The pointer is the head pointer. I shown you here. If you open this and you go inside Git, you will see something here. This is the point. Okay. So the pointer is pointing to it's pointing to the master branch. The author of that commit is Christopher Caroro or Christopher, and the email, this is the email. and the date of the commit, everything is shown here. It shows even the time zone. We're using +3, 5 p.m., 80 minutes past 5, and the label was my first commit. So remember, we have something in our staging area. You remember the staging area. If we run this command again, you see we have something here, not yet committed. So if we commit this again, git commit, then -m, and then maybe we say my second, sorry, my second commit. Bam. We are good to go. So our second commit is ready. Now, if we run the same command, so if we go to the staging area, look for the changes. Now there is no changes. We go back to our command git log, and now you see we have all these commits. The first commit is just there, and the second commit, my second commit, the label, the identifier, everything is there. And since we are working on the master branch, so the pointer or the snapshot of the commit is pointing to the master branch. Well. Let us go back to our slides. Now, if you have multiple files, you might sometimes have multiple files you're working on and you have multiple commits. So sometimes you want to only see the history of a particular file. Now, for now, you might not be in a position to see what this means unless we add another file. So let me go to a specific, let us create another file here. So another file, maybe we say echo, I will be writing a book. And this we store it as a text file. So we call it as book.txt. Now we're good to go. So if we say git status, we see now we have a book here, which is untracked. So what do? We say git, then add, and then book.txt. Okay. Then run, hit enter. So it's on the staging area. Then we commit. So we say git commit, and then -m, and we say maybe this is my book commit. Enter. So everything is there. Now, if we say git log, something like this, it shows everything. So it shows the first file has 2 commits, and the file I think was there was a file, I think it was readme, something like readme.md, and then now we create another file. But if you say git log, it shows you the history of everything. So when you want to see the history of a specific what? A specific file. So we say git log and then the file name. Now you see now this command here just produced this history here. So we were specific that we want to see the history of the file called book.txt. We can do the same, say git and then log and then say readme.what.md. You see, it will give you the command is here and the history is, you remember all these were commits for that particular what? For that particular file. Well, so this is how you track history. You will be able to see the number of commits that you have made in every file. If you want for a specific file, then again, you will you will be required to do what? To name that particular file. Naming that particular file will allow Git to only show history for that particular file. Another thing, let us come back here. Now, sometimes you want to see the details of a specific commit. Mhm. Uh, Including the changes that were made, then you have to use that particular commit. So if you go back here, sorry, if you go back here to emulator, I think now this is a commit, for example. This was our first commit. If we take this, if I am not mistaken, you will say then git show and then put that commit, that specific commit. Enter. You see what is happening? It is showing you even the details of the commit. But the details of the commit was what? There was a file created. This plus plus means that the file was created and the content was what? Added. Hello Git workshop here. So it is showing you everything. It shows that this was what? This was a new file and stuff and stuff. If you go uh, to the second commit, for example, do something like this again. This is the ID. So you can copy it and say git show and then put that specific commit so that you know exactly the details. So you see the details. Now, it didn't say new file as it did here because here it told us this was a new file. Now we don't have any new file, but it is showing us that something was what? Was added. And what was added was this line here in green, right? Now you understand. So basically up to now, we've been able to initialize Git. We've been able to check the Git status. We've been able to add files to the staging area. We've been able uh, to commit. We've been able to check the history. We've been able to check the details of a particular commit. Now, something also interesting is when you are making changes into multiple files. For example, if you come back here, let us open our visual uh, we have something here. We say in Visual Studio Code, another file is, let us open this folder first so that we can be able to, the folder is Git Workshop. This one here, select folder Git Workshop. We are good to go. Now we are able to navigate through different files. I trust the authors, then I open this. I'll be writing a book and then say the book will be about the governance. I hope it be the best selling book worldwide. I save, but still I go to my README file and I say, this is our first day in the workshop. We enjoyed it a lot. So you see, we have made multiple modifications, or we have made multiple modifications to multiple files. What does this mean? If we come to our emulator and git status, we see now that we have modified two files, the readme file and the book.txt file. All these files have been modified. Now, we said once we have modifications or changes being made, we must move them to the staging area so that we can be able to commit these changes. Now, what we are doing, we will write git add and then the file name. Now, imagine you have 10 files, 20 files that have been modified. Will you be able to every time add the file name, until you finish all the files? That will be cumbersome and tiresome as well. You'll be exhausted. Now, what do? You write a command that adds every file that has been modified. And instead of writing individual file names, you just put a dot or a period or whatever you call it. Git add dot means git add all. So every single file that has been modified will be added to the staging area. So if we hit enter, everything has been added. So you see the readme and the book.txt, all those files have been added. Now, if we go to the staging area, we will be able to find these files. You see, the first is readme. The readme. We see these changes in green. This is our first day in the workshop. We enjoyed it a lot. And then we come to the second file, which is book.txt, and it says the book will be about the governance, blah, 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 blah. So you see, we have been able to add two files at once by using the command git add all. And the all there is represented by what? By the dot. So now we can commit. We commit all the changes by saying git commit, and then minus m as always, and then we put a label. We say committing changes from multiple files. And we're good to go. So we have, if we say git status now, nothing, the working tree is clean. So that is another command that we have been able to see. And the command is what? Is that you can add multiple files together by using the command git add all, by using the dot. You can view commit history. We said git log, but you can add these these other parameters to see it you add these parameters so that you can add other information as you view the history. Let me copy this command. It is git log and then dash dash one line dash dash graph. And I'll tell you what it means. I'll tell you what it means. So this is git log minus minus one line minus minus graph. So you see now this is very clean. It's very clean. It's not the same as that in git log. You see the difference? Blah 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 blah. The command is written here, but the information is retrieved all these lines. And still, okay, we are at the end. Wait. So you see, this is different from this one here because this one here only shows what? Only shows a specific commit and the message. The specific commit and the message. It doesn't show anything uh, more than that. So that is git log, one line, then a graph. Well, uh, our session is 2 hours. We have almost 22 minutes to wind up. I hope maybe we can be able to reach somewhere. So after illustrating those commands and how you can move around and explore Git, actually we have been able to see. Uh, I mean, this is a kind of the workflow. You go from working directory, you use Git add to the staging area, Git commit to the repository. We said this is a three-step process from working directory to the staging area, from the staging area to the repository. And all the commands that we use to do all this stuff, I have just shown you. Now we come to this is very important, Git configuration. Git configuration. Now, I think you when I was writing commands here, such as the git log, for example. Let me clear it here. Git log. You see? For example, in the git log here, it gives the name. It also provides the email address. So this is the username. This is the email address of the author. So this doesn't come automatically. You must configure them. We have a lot of configurations, but this is just a sample of what we configure in our Git project. So in order for you to be able to see something like this or something like this, now, when you configure, for example, this is the author information. If you're working on a project managed by a team, that means every time you, for example, every time you push your changes into a remote repository, every commit will be identified also by the author name, will be identified by the author name. So whatever you write it here is what will be seen at the remote repository every time you commit. So this information are paramount. Now, how do we configure these and the likes? Now, back to our slide so that I can give you a little theory before we move to practice. So Git configuration means the settings that control Git behavior, identity, editor colors, blah, blah, etc. And the configuration are stored at different levels. So you can make configuration which are system-wide. If your computer is being used by multiple users, for example, then system means even if somebody logs into your computer using the different account, they will be able or they will be affected by the configuration. And the command is git, then config, and then dash dash system to mean that this is a system configuration. And for example, if you are setting a username, you will say user.name, and then you put the name. If you are configuring for global, what do we mean by global? Global is the current user. For example, when you log into sorry, I am not sure whether I've come out of. This is, for example, my screen here. So this is the user. I'll be logging into this account. But I might have multiple accounts. Now, when we say global, actually, global means the current user, but within this current user, you might have multiple projects. So every project that is Git tracked, it will be it will be recognizing the configurations that are set or are set as global, but they will not be affected to other users. So other users will not be able to see. When you use local flag here, it means this is to the current repository, to that current project, that current project. So local overrides global. So maybe in that particular project, you want to use different settings, different identifications, etc. You might use a local. So local overrides global and the global overrides system. So if we're talking about preference, it starts with local, then global, and then system. If you want to be able to see the current configurations, you say git config and then dash dash list. You can create an alias for common commands. For example, some commands are too long and you don't want that command to be that long, then you might use an alias so that every time you want to write that particular command, you'll use that alias. So we call it a nickname, in other words, an AKA. So when you write that AKA or a nickname or an alias, then the same command will take effect. So for me now, if we want to see the current configuration into my computer, what we do here, we say what? We say git, and then we say config, and then we say minus what? List. So you see, all these are the configurations in our computer. All these. Now, the common one that you might see, for example, the email is christopherkalolo@gmail.com. The name is what? Christopher, alias. I made an alias for commit. You see this alias, I said .c, I mean C is the same as writing commit and then -m, and I will show you how it works. So this is an alias. Instead of writing commit -m, I can just write C. And other information. So you keep pressing enter until you come to the end. You press Q for quit. So let me show you how the alias works, and we will configure. Okay, let me configure the branch because the branch is reading master. Let me configure it to something else. I say git config global, and then default. Is it default branch? I think it's default branch. Then say this is the same as what? Main. I hope this is. Hey. Okay, I will look on the correct way to name this branch. I think I have made an error, so I'll look for the way to check that. But for example, I told you that I use the C for commit M. Now, what happens is that if you come to your file, for example, so not this one. Yes, here. We enjoyed a lot. A lot. Now that is a change. So after making that change, I'll go and add to my emulator. I'll say git. If I say git status, something has changed, modified. Okay. Git add, I just add all the shortcut. I don't want to write the file name. And then I say git, instead of commit -m, I just write C, and then I write the message. The message is illustrating using alias. It works, you see? It works. So that works. So you can you can do anything you want. You can unset. Sometimes you don't want that configuration. You go and unset, etc., etc. So I will show you how to, for example, how to do a configuration or to perform a configuration setting. For example, I changed the name from Christopher to Mondesure. So I write git config, and then because I want it to be global as per this user, and I'll say user.name is equal to what? To Mwendisule. Hey, Mwendisule. Git config minus global. It user.name. I think I'm making a little mistake. Let me check the error.
Just put
I
space.
think I'm making a little mistake.
Is equal to.
Let me go back. There is no equal sign there, I think. Okay. So we have changed it to Mwendisule. Now if we say git config minus list, what do we have now for the user? Here, Mwendisule. So we managed to change. So the username now is Mwendisule instead of what? Instead of Christopher. That's how we do it. Okay, another thing to finalize today's session. So this is how you actually this is how you this is how you perform Git configuration. So the command starts with Git and then config. Then you put a visibility flag. The visibility flag is either system or global or local. So all these visibility flags are preceded by double hyphen. So hyphen system or hyphen global or hyphen local. If you want to change the username, you just say user.name. If it's email, then user.email. I've just forgotten the branch part. I will show you next time. But if you want to change, a particular command into an alias, then you put alias dot what you want. For example, we said instead of saying uh, for example, git log, for example, say git log, then minus one graph, one line, minus graph. So now this will be preceded by something like you say git config, and then minus, for example, global, and then it will say alias dot, for example, dot what? For that, maybe we want to .h for what? For log minus one line minus graph. So now if I say git log, git, and then I say h, you see what has happened? It has run. It has shown results as though we have written git log minus one line minus one graph, and this configuration will be seen if we say git config minus list. Then you are able to see the entry here. Alias.h equals to log minus one graph one line minus graph. So this is what has happened. So instead of writing that long line, we just use git h, and the results were the same. The results were the same. So that was Git configuration, my brothers and sisters. I think I'm remaining with a few issues. Remaining with just a few issues. So I will request that I use these 5 minutes to just elaborate, and then we close the session for today. So most of these things that I'm just explaining here, we have already been able to see. For example, we saw that in order for you to inspect and manage changes, we use these commands. So git add, git status, we want to view file states, git diff, we saw unstaged changes, git safe, git diff dash staged, when you want to see staged changes. I didn't show you git restore dash staged. If you want to unstage a file, but there is another command which is git checkout minus then the file name, if you want to revert changes in the working directory. So we have two commands here that we haven't seen the way they work. The first command is git restore minus stage when you want to unstage a file, but you want to keep the changes. And then another is git checkout, then the file name as a flag if you want to revert even the changes in the working directory. So I will be finalizing with that. Okay, I think we are okay. We are done. So, I will show you these two commands the way they work by showing you a real example. And the real example is what? We go to these files, for example. Go to these files. For example, we write another line. We say in the README, we say we are about to finish. We are about to finish. We save. Then we go to a command. Now remember, if you're using an IDE like this, you can open the terminal just right here, but I'm using the emulator there because I am making you understand the git bash something, but I can just run the terminals just right here. I'll show you later, but for now I'll be switching to and for 4. So now we commit that file. If we say git status, first let me clear here. Then git status, we see modified readme, so say git add all, and then what are we going to do? Okay, if we say git status now, You see, the file has been modified, but it has been staged. Now you are asked that if you want to restore a file but keep changes, you want to unstage. What do? You say git, then restore. All the Ligas command was reset. But you say restore and then minus minus staged. So if you say staged, that means every file, every change in every file will be unstaged. But if you want to a specific file, then you will add that specific file and say, for example, readme.what.md. If I tap, so we have one say. So now if we say git status now, you see, it is here, untracked. It is untracked here. So we said, okay, let us push it back. Not restore, we want to add again. I've added again. But we said there is a command which doesn't only unstage, but it also removes the change in the physical file. So if I say git checkout minus minus readme.md. Okay, I think there is a flag. Sorry, there is a flag which I must git check out. Now let us check the original file there. One file change, one insertion, one deletion. No, it wasn't able to. It wasn't able to. Git restore minus minus staged to unstage, git staged, and then if all file, then something like this. Sorry, readme.md, and then git check out readme.md. Updated one path. Let me see the original file. You see, we have deleted that line. The line was saying we are about to finish. So what do we get here is that? What do we get here? If we have staged the file, if you want to get rid of the changes, you must unstage it first. After unstaging, then you can get rid of the changes. For example, let me write it here again so that you see. I write the word World Cup and then I save. Now, since this file is not staged, I will just write the command right away. So just write the command git checkout readmd. Pop, update the one path from the index. So if we go, the line World Cup will not be seen again. It is not there. It is not there. So those two commands, you want to unstage, then you say git restore minus minus staged, and then the file name, and then after that, git checkout, then the file name to undo the changes in the working directory. Do we remain with anything here? Let me see if we do remain with anything. So when we say repository hygiene, actually, these are the basic practice that usually you must follow when tracking your files with Git. For example, configuration file that belongs to you and not to the team should not be pushed to the shared repository, which usually is the remote repository. Because when you push it there, what happens that a team member will pull that file. It will be part of their local repository. And if it has specific configuration to you, it might cause some conflicts. And in order for us to be able to manage that, we use a file called gitignore. So the file called gitignore, which is a hidden file, that's why it starts with a dot. Every file that starts with a dot is a hidden file. So when we write we create a file called .gitignore, inside that file we will be listing all the files that should be untracked. That should be untracked. It should not be tracked. Sorry, that should not be tracked. Hmm? So if the file is not a common file, that file will not be tracked if it is listed inside the gitignore file. So we use gitignore to prevent temporary sensitive or build files from being accidentally committed. Database configurations, for example, a file that contains your local passwords, etc. Because you might be working in a project and you are using your local database, right, to test the functionalities and stuff. That means you will have database configurations for your local database inside that project. You will have file that contains database configuration. If you don't list it in the gitignore file, you will accidentally push it. You will accidentally commit it because, for example, if you're using the command git add all, that means even that particular file will be added, and then when you commit it, the changes will be committed. If you push the change to the shared repository, that means another person will be able to see your credentials, the username of your database and the password as well. That means you will be exposing your secret information to other people. So your file will be listed as this one here. You can see this. The first line logs means this is a command, and then writing it this way means every file that ends with log should not be what? Should not be pushed. That's why it starts with the star.log, which means any file name ending with log. And then maybe you don't want to commit node modules slash means all the files inside the folder or the directory node modules, etc., etc., etc. So all these files will not be what? Will not be committed. So I am leaving you with this. Create a gitignore file, add rules, and test by running git status. Or if you want, let us create it quickly here. So I will do something like clear, then touch git ignore. So we have successfully created the file. Now let us try to create another file called, for example, logs.txt, right? And then enter. Equal server down. We've written that line. Now, what do? we want to add this file to the gitignore file. So we'll say, for example, echo logs logs.txt. We write it into .git ignore. Okay, so if we come to our code editor here, we find the file gitignore there, we find the file logs.t blah blah. So if we say we see in gitignore we have logs.txt. So let us do something like git server, because this now has got content server down. It's a new file, which means if we say git status, it must be the git status for new files. But you see, the only new file that we see is gitignore. Now, even the gitignore should not be tracked. Should not be what? Not be tracked. Now, how do you include gitignore? Now you see the logs.txt is not there. If we delete that line, in gitignore logs.txt, delete that line and then save. Now, when we run git status, also logs.txt will be included. Let me clear the screen. So git status, you see, we have gitignore and logs.txt. Now, since these two files should not be committed, should not be tracked, what we do is we make sure that the two files are part of the gitignore file. So the gitignore file will also list itself in order for it to not be tracked. We add it here. So we have the logs.txt. We save this file in the gitignore. Now, if we go back here, if we say git status again, we won't be able to see the two files. It says the working tree is clean because these two files has been added as files not to be tracked. And this is what we call the hygiene, repository hygiene. Repository hygiene. So every time you're working with sensitive files that should not be shared, make sure that they are added to what? To your gitignore file. The git keep actually is a placeholder for file to force Git to track otherwise empty directories, because empty directories cannot be tracked. They can't be tracked. So if you want to track an empty directory, what you do, you add a git keep. It has nothing to do, but it's just there to make sure that the folder or the directory is tracked. Only that. So it's not a conventional file. It's not a conventional file. So for example, if we say we create a folder, if we create a folder, sorry, if we create a folder, say make director and say maybe uploads. That is a folder. Remember, if we say git status, you can't track a folder. So if you want to track that folder, you intentionally put an empty file that does nothing inside it so that the folder will be tracked. So you say, for example, touch uploads / dot what? Git keep. Now this time around, if we say git status, you see now we're able to track the folder. That's what I'm saying. You want to track the folder, you can add the git keep hidden file as a placeholder so that the folder will always be tracked. That is otherwise, for today's workshop, we are ending here. I think the project files, the workshop files will be available on the Google Drive link, which I will share later. But also, I think the video will also be available. I will share it via my Google Drive. For now, you can create a Git repo yourself to simulate project tracking. You can screenshot this page here and just do whatever this task is asking you to do and see how you can go around exploring Git commands by using this mini project. Thank you very much for being here. I would like to ask if someone has anything to ask. If nothing to ask, then I will be calling it a day. Should there be anybody who wants to ask a question? Please, 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 you are most welcome. Just ahead, George Hayuma is raising a hand. Please, welcome. You can unmute yourself and ask whatever you want to ask.
Ni mimi tu nataka kusema asante.
Oh, thank you, Mr. Leguma. Thank you. I'm happy that I have heard your voice. I'm happy that you were here. So, guys, for the next session, which will be the next Saturday, we will be discussing about, let me quickly check it here. So, our next session will be branching, merging, and collaboration basics. Branching, merging, and the collaboration basics. Please be here. We will start exactly at 4 p.m. And after 2 hours, we'll be winding up our session. Thank you very much. And God bless you.
Thank you, sir.